According to the National Electrical Code, the following circuits are required to be on separate dedicated circuits: dishwasher, microwave, and refrigerator. The counter to ground fault circuit interrupter receptacle circuits can be combined, but each circuit should not exceed 80% of its ampacity rating. If your current circuit configuration has the dishwasher and microwave on the same circuit, that does not satisfy code. The refrigerator is currently on a separate circuit, which is correct. To bring the circuit configuration up to code, you will need to create a separate 20-amp circuit for the dishwasher, create a separate 20-amp circuit for the microwave, and combine the 4 counter to ground fault circuit interrupter receptacle circuits onto one circuit, provided it does not exceed 80% of the circuit's ampacity rating. Firstly, ensure that the circuit breakers and wiring are rated for the appropriate ampacity of the appliances being connected. Dedicated circuits provide a dedicated power supply to each appliance, preventing overload and electrical hazard. Ground fault circuit interrupter protection is required for all outlets within 6 feet of a water source, such as counter outlets. It is recommended that you contact a licensed electrician to assess the existing circuit configuration and make the necessary modifications to ensure code compliance and electrical safety. Let's delve deeper into the electrical code requirements for kitchen circuits, focusing on dishwashers, microwaves, refrigerators, and ground fault circuit interrupter receptacles. Understanding these regulations is crucial for ensuring safety and compliance in residential electrical installations. We'll break down each component and the specific code requirements associated with them. First, let's discuss dishwashers. The National Electrical Code mandates that dishwashers be on a dedicated circuit. This means that the dishwasher should have its own individual circuit breaker in the electrical panel, supplying power only to the dishwasher. Typically, a 20-amp circuit is required for a standard household dishwasher. This dedicated circuit helps prevent overloading the electrical system, which can lead to trip breakers or, in more severe cases, electrical fires. The wiring for the dishwasher circuit should be appropriately sized to handle the load. Usually, 12 American wire gauge copper wire is used for a 20-amp circuit. Make sure that all connections are secure and properly insulated to prevent shorts or ground faults. Now, let's move on to microwaves. Similar to dishwashers, microwaves also require a dedicated circuit. Microwaves consume a significant amount of power, especially during operation. A dedicated circuit ensures that the microwave receives a stable and uninterrupted power supply. A 20-amp circuit is generally recommended for microwaves as well. This prevents the microwave from drawing excessive current from other appliances in the same circuit. Using the correct wire gauge is essential. Again, 12 American wire gauge copper wire is typical for a 20-amp microwave circuit. All connections should be tight and secure. Now, let's discuss refrigerators. The National Electrical Code requires refrigerators to be on a dedicated circuit. Refrigerators operate continuously and need a reliable power source to maintain consistent temperatures. A dedicated circuit prevents voltage drops and ensures the refrigerator functions efficiently. A 15 or 20 amp circuit is commonly used for refrigerators, depending on the specific model and its power requirements. Check the manufacturer's specifications to determine the appropriate circuit size. The wiring for the refrigerator circuit should be sized accordingly, typically 14 American wire gauge for a 15 amp circuit or 12 American wire gauge for a 20 amp circuit. Now let's discuss ground fault circuit interrupter receptacles. Ground fault circuit interrupter receptacles are crucial for safety in areas where water is present, such as kitchen countertops. The National Electrical Code mandates ground fault circuit interrupter protection for all receptacles serving countertop surfaces within 6 feet of a sink or water source. Ground fault circuit interrupter receptacles are designed to detect ground faults, which occur when electricity flows along an unintended path, such as through a person. When a ground fault is detected, the ground fault circuit interrupter receptacle quickly shuts off the power to prevent electrical shock. It is possible to combine multiple ground fault circuit interrupter receptacles on a single circuit, but it is essential to ensure that the total load does not exceed 80% of the circuit's ampacity rating. For example, If you have a 20 amp circuit, the total load should not exceed 16 amps. This helps prevent overloading the circuit and tripping the breaker. When installing ground fault circuit interrupter receptacles, it's essential to follow the manufacturer's instructions and local electrical codes. Ensure that the receptacles are properly grounded and that all connections are secure. Test the ground fault circuit interrupter receptacles regularly to ensure they are functioning correctly. The test button on the receptacle can be used to simulate a ground fault and verify that the receptacle trips as expected. In summary, the National Electrical Code specifies that dishwashers, microwaves, and refrigerators must be on dedicated circuits to prevent overloading and ensure a stable power supply. Ground fault circuit interrupter receptacles are required for countertop outlets within 6 feet of a water source to protect against electrical shock. When combining multiple ground fault circuit interrupter receptacles on a single circuit, make sure that the total load does not exceed 80% of the circuit's ampacity rating. Always consult with a qualified electrician to ensure that your electrical installations comply with all applicable codes and regulations. This will help create a safe and efficient electrical system in your home. Moreover, let's elaborate on ampacity and its importance in electrical circuits. Ampacity refers to the current carrying capacity of a conductor, which is the maximum amount of electrical current that a wire can safely carry without overheating. The National Electrical Code provides tables that specify the ampacity of different wire sizes and types, taking into account factors such as insulation material, temperature rating, and installation conditions. When selecting circuit breakers and wiring for appliances such as dishwashers, microwaves, and refrigerators, it's crucial to ensure that they are rated for the appropriate ampacity. Using undersized wiring or circuit breakers can lead to overheating, insulation damage, and even electrical fires. For example, if you have a dishwasher that draws 10 amps, you should use a 20 amp circuit breaker and 12 American wire gauge copper wire, which has an ampacity of 20 amps under normal conditions. This provides a safety margin and prevents the circuit from overloading. Dedicated circuits, as mentioned earlier, are essential for preventing overload and ensuring a stable power supply to appliances. When multiple appliances are connected to the same circuit, the total current draw can exceed the circuit's ampacity, causing the circuit breaker to trip. Dedicated circuits provide a separate power supply for each appliance, eliminating the risk of overloading and ensuring that each appliance receives the necessary power. Ground fault circuit interrupter protection is a critical safety measure in areas where water is present. Ground fault circuit interrupter receptacles are designed to detect ground faults, which occur when electricity flows along an unintended path. This can happen when an appliance is damaged or when someone comes into contact with a live wire. When a ground fault is detected, the ground fault circuit interrupter receptacle quickly shuts off the power to prevent electrical shock. Ground fault circuit interrupter receptacles are required for all outlets within 6 feet of a water source, such as kitchen countertops, bathrooms, and laundry rooms. They are also required for outdoor receptacles and any receptacles that may be exposed to moisture. Testing ground fault circuit interrupter receptacles regularly is essential to ensure they are functioning correctly. The test button on the receptacle can be used to simulate a ground fault and verify that the receptacle trips as expected. If a ground fault circuit interrupter receptacle fails to trip when tested, it should be replaced immediately. In addition to the specific requirements for dishwashers, microwaves, refrigerators, and ground fault circuit interrupter receptacles, there are other general electrical code requirements that apply to kitchen circuits. These include proper grounding, bonding, and overcurrent protection. Grounding provides a path for fault current to flow back to the electrical panel, allowing the circuit breaker to trip and prevent electrical shock. Bonding connects all metal parts of the electrical system together, creating a low impedance path for fault current. Overcurrent protection, provided by circuit breakers or fuses, protects the wiring from overheating due to excessive current flow. It is essential to consult with a qualified electrician to ensure that your kitchen electrical system complies with all applicable codes and regulations. An electrician can assess your existing wiring, determine the appropriate circuit sizes and wiring gauges, and install the necessary safety devices. They can also provide guidance on energy-efficient lighting and appliance options. Remember, electrical work can be dangerous, and it's always best to leave it to the professionals. Working with electricity requires specialized knowledge and skills, and mistakes can lead to serious injury or even death. By hiring a licensed electrician, you can ensure that your electrical system is safe, reliable, and code compliant. Let's further explore the nuances of electrical code compliance for kitchen appliances, focusing on practical considerations and common pitfalls. First, let's discuss the importance of load calculations. Before adding any new circuits or appliances to your kitchen, it's essential to perform a load calculation to determine the total electrical demand. This involves adding up the wattage of all the appliances and lighting fixtures that will be connected to the circuit. The load calculation will help you determine the appropriate circuit size and wiring gauge to use. The National Electrical Code provides guidelines for performing load calculations, taking into account factors such as the square footage of the kitchen, the number of small appliance circuits, and the type of appliances being used. It's essential to follow these guidelines carefully to ensure that your electrical system can handle the load. Now let's talk about small appliance branch circuits. The National Electrical Code requires that kitchens have at least 220 amp small appliance branch circuits to serve countertop receptacles. These circuits are designed to handle the load of small appliances such as toasters, coffee makers, and blenders. The small appliance branch circuits should be separate from the general lighting and receptacle circuits in the kitchen. This prevents overloading the circuits and ensures that there is sufficient power available for small appliances. The countertop receptacles served by the small appliance branch circuit should be spaced no more than 48 inches apart, so that no point along the countertop is more than 24 inches from a receptacle. This ensures that there are enough receptacles available to meet the needs of kitchen users. Let's discuss the requirements for lighting in the kitchen. The National Electrical Code requires that kitchens have sufficient lighting to provide adequate illumination for cooking and food preparation. This can be achieved through a combination of general lighting, task lighting, and accent lighting. General lighting provides overall illumination for the kitchen, while task lighting focuses on specific areas such as countertops and sinks. Accent lighting highlights architectural features or decorative elements. The lighting fixtures used in the kitchen should be energy efficient and provide adequate light output. Light-emitting diode lighting is a popular choice for kitchens due to its energy efficiency and long lifespan. The lighting circuits in the kitchen should be separate from the small appliance branch circuits and the dedicated appliance circuits. This prevents overloading the circuits and ensures that there is sufficient power available for lighting. Let's explore the grounding and bonding requirements for kitchen circuits. Grounding and bonding are essential for electrical safety, as they provide a path for fault current to flow back to the electrical panel. The National Electrical Code requires that all metal parts of the electrical system be grounded and bonded together. This includes metal conduit, metal boxes, and metal appliance housings. Grounding is typically achieved by connecting the metal parts to a grounding electrode, such as a ground rod or a metal water pipe. Bonding is achieved by connecting the metal parts together with bonding jumpers. The grounding and bonding connections should be made with approved connectors and should be tight and secure. It's essential to follow the National Electrical Code requirements for grounding and bonding to ensure that your electrical system is safe and reliable. Finally, let's discuss the importance of documentation and labeling. It's essential to keep accurate records of all electrical work performed in your kitchen, including circuit diagrams, load calculations, and inspection reports. These documents will be helpful for future maintenance and repairs. The electrical panel should be clearly labeled to indicate the circuits that serve the kitchen. This will make it easier to identify and troubleshoot electrical problems. The circuit breakers should be labeled with the appliances or areas they serve. The label should be legible and durable. By following these guidelines, you can ensure that your kitchen electrical system is safe, efficient, and code compliant. Remember to consult with a qualified electrician for any electrical work that you are not comfortable performing yourself. Electricity is dangerous, and it's always best to leave it to the professionals.